Right now, we live in an era of digital silos. You open one app to hail a ride, another to order food, and a completely different one to check your schedule. Your data is trapped inside these single-purpose structures, functioning purely as stagnant storage that is isolated from the rest of your digital life. Large language models attempt to bridge these gaps, but current agentic systems do not possess true intelligence. They function as statistical guessers. They act as brute force engines, stitching together disjointed API calls by predicting the next logical word in a sequence, rather than reasoning through a specific task. This diagram shows the consequence of that brute force approach. A single task fractures into a tangled web of dead-end paths. These systems generate bloated, computationally heavy code. At scale, the sheer weight of this micro-inefficiency threatens to crash the systems entirely. This technical failure is compounded by a specific economic crisis at the foundation of the internet, the open-source free rider problem. Much of the digital world runs on open-source logic, maintained by a handful of unpaid volunteers, while corporations build billion-dollar products on top of it. Here we see the mechanics of that market failure. Transactional revenue models allow value to move strictly upward toward corporate capstone nodes. The final product is rewarded, while the foundational creators at the base are starved of resources needed to keep the system running. Taking power from the roots eventually kills the entire tree. Preventing a collapse requires moving away from isolated platforms and toward a system where data and economics are fused into a single high-resolution network. In this future, you rarely open a specific application. Instead, task-specific apps are replaced by a global orchestration layer. This layer pulls from a unified knowledge graph, allowing the system to synthesize data that used to be walled off. Within this orchestration layer, autonomous AI agents scan a universal registry of executable semantic actions. They evaluate the systemic value of these actions and actively deploy them to achieve high-level goals. This diagram illustrates how those actions are chained together. When a weather disruption node detects a severe storm, the orchestration layer pulls that data and instantly triggers new pathways across agricultural and shipping nodes, rerouting global logistics to bypass the delay before it even happens. Managing automated networks at this scale requires absolute precision. Statistical guessing is no longer viable. The necessary standard becomes formal verification, a mathematical proof that a specific piece of logic will execute perfectly without generating computational waste. To achieve this, the architecture fuses neural networks for pattern recognition with symbolic AI for logic. The system writes the code, tests it in a simulated sandbox, and strips away everything except a clean, singular path, a mathematically perfect microbinary. Stripping away this computational bloat is an absolute prerequisite. If agents make thousands of simultaneous decisions, even minor inefficiencies would make the cost of compute high enough to crash the orchestration layer. Paying for this infrastructure requires a different economic model. Instead of charging users transactional tolls, the ecosystem implements an automated systemic impact tax. Capital is captured based on the revenue-generating impact a piece of code has further down the chain. The deployment standard for this code is the self-metering protocol. This allows open-source logic to exist as a live asset that actively tracks its own utility within the broader network. Here is how that impact is calculated. When an AI agent strings together complex actions to achieve a valuable outcome, the system analyzes the dependency tree. It then automatically triggers resource streams that flow downward to the original creators based on the precise weight of their contribution. When a protocol generates more tax than it takes to run, the excess capital is sealed within a protocol-level escrow. This is managed by an autonomous AI authority that functions as a global, neutral product manager. This AI authority awards capital based on proof of capability. It checks a verifiable ledger of historical code efficiency. When high-trust nodes, teams with a history of shipping optimized code, submit a proposal for a new build, the system instantly unlocks the resources they need. This automated treasury removes the friction of traditional fundraising. It replaces venture capital negotiations with a system that starves rent-seeking and directly fuels the logic that the world actually uses. By automating the flow of capital, the system removes months of fundraising, legal friction, and venture negotiations that currently stall progress. Resources move at the speed of the code itself, allowing human talent to stay focused entirely on building and iterating. This unified digital architecture eventually translates into physical optimization. A coordinated data web directs decentralized manufacturing hubs to produce precisely the goods that local populations require, exactly when and where they are needed. When supply chains are optimized to this degree, the distance between a local need and its fulfillment disappears. Decentralized hubs can produce essential resources with such high efficiency that the cost of meeting basic needs, like food and medicine, drops toward the cost of raw materials, making them accessible to populations previously priced out of global trade. In this system, the role of the developer shifts. Humans no longer spend their time writing isolated database queries or fixing repetitive UI bugs. Instead, they begin operating at the highest level of abstraction. Human talent functions as the system's ethicists and architects. They define the parameters of value, set the logical boundaries for how AI agents negotiate, and design the macro structures that govern digital reality. By aligning economic incentives with algorithmic truth, developers are constructing a unified digital nervous system, building an infrastructure that finally aligns the production of the world with the actual needs of the people living in it.